Hello friends, ready for exam revision 2023? Let's have a look. In electromagnetism, we are going to discuss self-inductance, mutual inductance and eddy currents. You know very well that changing magnetic field generates induced current. And also, when current changes in a coil, magnetic flux linked with that coil also changes, and so EMF is induced. But self inductance opposes the change of the current. Its SI unit is Henry or Weber per ampere. 1 Henry is equal to 1 Weber per ampere. And formula for self inductance is E is equal to minus L di by dt, where L is proportionality constant, E is equal to induced EMF, and I is equal to induced current. So now the purpose of an inductance is to oppose any change in current within a circuit, and this property is known as inductance. So, to understand inductance, you must know that changing electric current produce magnetic field and changing magnetic field produce electric current. And here are the uses of self-inductance. So now what happens in mutual inductance? It depends upon Faraday's law. When two coils brought in proximity to each other, magnetic field is generated. Why? Because the magnetic field in one of the coil tends to link with the other, and that's why electric current is generated. And what is SI unit? SI unit is Henry, which is same as self-inductance. Mutual inductance principle is used in charging basis. So now moving towards eddy current. What is eddy current? So when conductor travels through magnetic field or magnetic field around stationary conductor changes, then eddy currents are produced. You must notice that in eddy current, due to resistive losses that transforms some form of energy, such as kinetic energy, into heat, means heat is generated due to energy loss. Now, one more thing, eddy current losses. In eddy current of magnitude I, if it flows through a core path of resistance R, then it will create heat energy according to power is equal to I square R formula. And that energy is almost unused, so it is called eddy current losses. So eddy current losses is calculated by the formula KEF square B max square T square, where Ke is equal to pi square by 6p. You must notice the process of making butter from buttermilk. When you move spoon anti-clockwise, some pattern is generated. When you move spoon clockwise, another pattern is generated, and that pattern is somewhat disturbed, and that is similar to eddy current. And what are the uses of eddy current? It is used in electricity meter in your house and electromagnetic braking, and it is used as metal detector also. Eddy currents are currents in electrical loop by changing magnetic field. So now it's very clear that it opposes the motion of a conductor. So it is used in electromagnetic damping. Eddy current flow in a closed loop in a plane perpendicular to magnetic field. So now the things are very clear in your mind that inductance is a property that opposes the changes. We, the humans, are also reluctant to changes, you know very well. So this law describes human nature also. So now everything is clear in your mind about eddy current, self-inductance and mutual inductance. Here is the difference between self-inductance and mutual inductance. Self-inductance change is opposed by coil itself, while in mutual inductance, one of the coil out of these two coils opposes current flown through it. In self-inductance, L is equal to N phi by I, and mutual inductance, M is equal to mu 0 mu R N1 N2 A by I. So for self-inductance, phi is equal to Li, and for mutual inductance, phi is equal to Mi. In self-inductance, L depends upon geometry, shape and size of the inductor coil. And now you know very well what is L, mu, and A. And now here is the answer of your question, what is back EMF? So that's all for this video. Thank you for watching my video.